Hello and welcome. So in this tutorial we will learn to make a T flip-flop. So if you have gone through my previous tutorial where we made a T flip-flop, you would be quickly able to learn how to make a T flip-flop and simulate it. So if you have not gone through my previous tutorial, it is highly recommended that you go through it before this tutorial. So now let's add uh, this new source. Uh, Select this Verilog module. Let's name this flip-flop as TFF since it is a T flip-flop. Click next, next, and finish. So in a T flip-flop, we have an input T. In fact, first specify the output Q, input T, and a clock, and also a reset. Right. So now you specify which one of these are inputs. So it's clearly this T, CLK, and RST are inputs, and Q is the output. But in case of behavioral modeling, we specify output as of type reg. So let's do that. Okay, so now let's start writing the code. So let's first write this always command and specify the execution criteria. So we want to execute this always block on positive edge of the clock. And also whenever there is a positive edge of the reset input, we also want to make some changes in the behavior of the circuit. So we want to execute our T flip-flop on positive edge of the clock as well as on the positive edge of the reset. Okay, so let's specify this begin statement and this end statement. So and then first write this if statement where we say that if RST is 1, the flip-flop should be reset. That means Q should be equal to 0. Else, so if this RST is not equal to 1, which means now the flip-flop will work in its traditional manner. So we know that in T flip-flop, uh, this T flip-flop works as an inverter if the input T is 1, and in case the input T is 0, there is no change at the output, right? So if input T is 1, this means we need to specify that Q should be the inverted version of itself, right? And in case or in otherwise case, Q should not change, right? So it means Q should be equal to Q, right? Okay, so and it is important that we begin this block because we have more than one statements in this else block. So whenever we have more than one statements, we use this begin and end block to make a new block of the code, and then we end it as well, right? So okay, I guess That's it. Let's save this and run its behavioral check. It's fine. Now let's write a test bench. So let's add a new source. Select the Verilog test fixture. Write tb underscore tff. Click next. Let's select this tff. So click finish. Right. So here we are. So now let's specify inputs and outputs. So initially we keep this CLK, the clock is 1. Reset, we want to keep our flip-flop at reset initially, and let's say input is also 1 initially, right? So it doesn't matter because the flip-flop is at reset, so it doesn't matter what is the input, right? So now once we have done that, let's now copy this. After 100 nanoseconds, what we want to do, we want to remove the reset condition. So we want to make RST equals to 0. So we will specify the clock later, and let's make t is equal to 0. And now after say 100 nanoseconds, let's make t is equal to 1. And again after say 10 nanoseconds, let's make t is equal to 0, right? So since in binary and in decimal the 0 and 1 are same, so we can so when if we are specifying a 1-bit input, it is okay to write 1 like this. But if we are specifying say more than 1-bit binary number, then we need to use its traditional format, that is we should specify number of bit first and then write the type. Here again we should do the same. Right, so let's save this. Okay, so now let's specify the clock. So in clock we use this always block and specify that after, so we first specify the time delay. So let's say after 10 nanoseconds, after every 10 nanoseconds the clock should reverse. So we do this like that. So let's now save this. Now run its behavioral check. So it's perfectly fine. Now we simulate the file again, right? And now we are ready to simulate it. Right, so here we are. This is the simulation results. Now click this zoom to fit, and as you can see, until this reset command is reset input is 1, the output is 0. But as this reset goes to 0, input also goes to 0, and as you can see, the flip-flop stays at 0. But as you can see, after this transition for 10 nanoseconds from 0 to 1, now the flip-flop has inverted, and so it will again invert if there is another input pulse of transition from 0 to 1, right? So this is how the T flip-flop works.